Hi people, notes 3.3 are on direct variation, and once the notes start, it's going to say notes 3.5 on top, but you are watching the right video. This should be notes 3.3.
And the first thing that we need to do is define what direct variation is. And direct variation is a relationship that has a constant rate of change and an initial value of 0. It needs both things in order for it to be considered direct variation. So let's talk about how we might see these kinds of situations. So first of all, let me give you an example of something that would be a direct variation. So an example would be you are paid $15 per hour. So your graphical representation would look as follows. We would put time on the x-axis because time is the independent variable. We would put pay on the y-axis because your pay depends on how many hours you work. And if you don't work, you don't make any money, right? So if you work 0 hours, your pay is 0. So if you work 0 hours, your pay is 0. So this right here is your initial value. Do you see how you are starting at 0? And then every hour you work, so we'll say these are 1, 2, 3, 4 hours, you get paid $15. And this is just a rough sketch. So 15, 30, 45, and 60. So here 1 hour is 15, 2 hours is 30, 3 hours is 45, and 4 hours is $60. And if you notice, the line is straight. It's not changing the steepness of the line. So because the line steepness is staying the same, that tells us we have a constant rate of change. And because it starts at 0, it tells us we have an initial value of 0. A numerical representation would be in a chart. So we would have time, which is measured in hours here, and then we would have our pay, which is measured in dollars. And same thing, initial value, you don't work, you work 0 hours, you get paid $0. You work 1 hour, you get paid $15. You work 2 hours, you get paid $30. 3 hours, $45, so on and so forth. So this is a numerical representation because you have numbers or coordinates to represent what's happening in this situation, okay? And then lastly is an algebraic equation, which is represented by an equation. So pretty much all that's happening here is that your pay is equal to $15 for every hour, starting at $0 for 0 hours. Okay, so we have different representations of a direct variation. So let's look at our example. Rhonda bought sesame snacks at the bulk food store. The cost was $1.10 per 100 grams. So part A says to create a table of costs for different masses. So this is our numeric representation. Okay, so we have masses. This is our independent variable and it's being measured in grams. And our dependent variable is the cost in dollars. And we know the cost is dependent because the cost depends on how many grams you buy. Okay, but if you go to the store and you don't buy any, you pay $0. So here we're showing that it's starting at 0. If you buy 100 grams, you would pay $1.10. If you buy 200 grams, you'd pay an extra $1.10, so now we're at $2.20. If you buy 300 grams, you pay an extra $1.10, so now we're at $3.30. 400 grams would bring us to $4.40, and then 500 grams would bring us to $5.50. So here's our numeric representation. Our graphical representation is going to be shown right here. Create a graph of your table. So our independent variable is our mass, and we'll put this in grams. And then our dependent variable is our cost, and that is measured in dollars. And we have to include 0 in this bottom left-hand corner at the origin, okay? And for my mass, I will say I will put 100 here, 200 here, so on and so forth. And then for cost, we're going up to around $5. So I will say this is $1, $2, $3, $4, and $5. And obviously each one in between is going to be 50 cents because it's halfway between each dollar. So we know that if I buy 0 grams, I will pay $0. I'm not going to pay anything at all. We know that for 100 grams, we will pay $1.10. So I will go to 100 grams here, and then I will go up to $1.10 right here. So this is where my point is going to be. We know that 200 grams would be $2.20. 300 grams is $3.30. 400 grams is $4.40. And then the 500 grams won't fit. That's totally fine because I am going to draw a line with an arrow at the end, and the arrow right here will tell us that this will go on forever. Okay, notice how it starts at 0 and we have a constant rate of change because our steepness of our line is constant. Okay, all right, so now for part C, it says to determine the rate of change for the cost of sesame snacks per gram. So we have a couple ways that we can do this, but regardless, whenever we find our rate of change right here, we always do rise over run. So if you look here, I'm going to show you a few different ways that we can do this. We can see here that this rose by $1.10, so this is the rise. And we know this one's the rise because the Y is always the rise. Rise is up and down. And this right here is the run, and it's 100. So here we can say the rise is $1.10. The run is 100 grams. Remember, the run is XY, and this is our X right here. And when we divide 110 by 100 grams, $1.10 divided by 100, I get 0.011. And at this point in time, we do not want to round our answer, so we'll just leave it at $0.011 per gram, or 1.1 cents per gram, okay? Another option that we have is we could do the rise over the run right here. We can see here that the rise is $5.50. Here the run is 500 grams. Let's go ahead and divide those two numbers. I still get that 0.011, okay? And you can choose any starting point, any ending point, it's up to you, and you'll still get the right answer if you do it correctly. Another option is to do rise over run using your graph right here. So I could also just choose a starting point, so I can start here and end here, and I know that the rise went up by $2.20 because this up here is 440 and this down here is 220, and when I do 440 minus 220, I get 220. So we know that the rise is 220. And then the run, we know the run it goes from 200 to 400. Right here is 200, right here is 400. So 400 minus 200 is equal to 200 grams. So to do this, I would just do 220 divided by 200, $2.20 divided by 200 grams. And I still get that 0.011. So it doesn't matter how you want to do it, you'll still get the same answers. All right, our last representation says to create an equation to represent the situation. And so this is our algebraic representation. So we know that the cost per gram is 0.011. So we know that how much we're paying, the cost, is equal to 0.011 for every gram. So then that's why we would say C equals 0.011 G. Okay, and okay, in part E, it says use your equation to determine the cost of 450 grams of the sesame snack. So here we know that this right here represents the G. So it asks us to use our equation. So we start by writing down our equation. And now we know that the G right here is 450. So every time I see a G, I'm going to replace it with 450. So I'm going to say C equals 0.011. And instead of G, I'm going to put 450. And this right here is multiplication. So 0.011 times 450 right here gives me $4.95. So we know that the cost of 450 grams of the snack is $4.95. Now let's look at our graph right here. 450 falls right here, and if I go up here, I can see, oh, it's almost $5, so that $4.95 definitely seems to make sense, okay? And then lastly, it says Rhonda has $4. What is the maximum amount of sesame snack that she can buy? So we're going to use our equation again. And we know that she has $4 and that's the cost. So this time I'm going to put the 4 in for the C. So I'm going to say 4, and then I'm going to copy the rest of this equation down. So 4 equals 0.011 G. To solve for G, I have to get rid of that multiplication, and the opposite of multiplication is division. And whatever I do to one side, I do to the other side. So I have to divide 4 by 4 by this 0.011, and I end up getting 363.6363, so on and so forth. So we can say, therefore, Rhonda can buy a maximum of 363 grams of her snack. Okay, let's check to see if that's right in our graph. So we know that she has $4. So if I go over to $4 on my graph, I can see here that this will fall a little bit after 350. So 363 definitely seems like an answer that makes sense. And that's it for direct variation. If you have any questions, let me know. Otherwise, I will see you in class. Bye.